Hello, YouTube. My name is Luis, and today I will be going over the materials for week one of CS 4540. This week's topics are Python and neural networks. And so we will be going over three key uh, resources for this discussion. The first one being an introductory course to AI Python for beginners through Deep Learning AI. The second source will be a YouTube video titled "But What Is a Neural Network?" Given by Three Blue One Brown on YouTube. And the third source is also a YouTube video titled "Universal Approximation Theorem." And so we will be going over those two videos, not too much into detail, but just laying out the main points of the video or what I was able to take away from it. So let's get started with the first source, which was the beginner's course. Now, this course mainly covered introductory lessons on Python, but also integrated into that were some utilization of AI chatbots, as you can see on the right. So on the left, we see the introductory course to commenting and printing statements in Python, right? So you have lines that uh, are, for the most part, ignored when running code. These are mainly for the user, the one typing the comment in to use, not so much for the program to use. But or statements such as print statements will be executed as normal. And then we used AI chatbots in the course uh, predominantly to correct or go over any issues in our code that we might run into, right? So you would copy and paste portions of code that are not working as you may have wanted them to, and also provide the chatbot with a prompt. So you can say something along the lines of, given this code, can you tell me what's wrong or how would I go about fixing it? And the chatbot will actually go ahead and provide examples for how to fix the specified code. And in this example, it gives actually two ways of correcting the code. And so there are many ways of going about fixing a code based on what prompts you give an AI chatbot, what sample codes, and what exactly you're asking the AI chatbot to do. And so we're given a glimpse as to how many of these errors can go about being fixed, whether it's by yourself or with the help of an AI chatbot. Then the course moves on to talking about data types and calculations. So we talk about strings, we talk about floats, we talk about doubles, and these are all different types of data that hold different values, right? Depending on what it is that you're needing something like a variable to do. Uh, and then we also get an introduction to how to run any type of calculations on Python. So it could be something as simple as having numbers with operands, and the program will run those as soon as you run the code, which you can use later on depending on what the circumstances are for that calculation. And those two actually go hand in hand when you look at storing results of calculations into uh, some variable and then having those values be used later on in your code. And so you can actually use functions that are built into Python, such as what you see on the left hand side type, with the variable or the calculation put into the parentheses, and then the Python code will actually return what data type the variable is. And so while we don't really use stuff like that by itself, this does play a key role into using data types in your everyday code as a programmer. And then the newest portion of the introductory course, the one that holds the most, well, I would say the most value, is the introduction to LLM prompts with data. And so we start off the course with learning how to import the library, the database for LLM prompts into your Python code. And then afterwards, you can, program as usual, give certain variables, give certain values to your code. But what's interesting about this is that you can actually use that variable, that data, into the prompt that you would otherwise use for an AI chatbot that actually updates with real time as you change the value of the variable within your code. And this LLM prompt can reply to prompts that you give it. So you give it something like a number, right? And then you tell it something along the lines of, give me a code with this specified amount of lines. And the specified number of lines is the variable that you input into the prompt. And the LLM prompt will return whatever it is that you're asking it. And this result can change depending on what the value of the variable holds. And it's just a really cool way of, you know, updating your variables, seeing how it affects what an LLM prompt bot will return when given a specific prompt and value to work with. So we start with the YouTube video, but what is a neural network? And what the video entails is that a neural network is a series of neurons which act as uh, what you would call maybe a cell. But what's important is that it holds a value, it holds a function, it holds some type of weight to it. And there are various layers in a neural network that behave similar to a brain, in which the network will recognize patterns based on the values of the neurons. And what this does is that with each layer, a pattern is recognized. And so inferences based on the input will, lean the network into believing or going towards a particular answer, a particular output. So, given an input like a picture, each pixel in the picture is acts as a neuron, acts as something that holds a value, right? And when you're given all of those neurons, the layers within a neural network will recognize each pixel as being part of a pattern. And once it recognizes a pattern up to a certain point, it'll be able to correctly identify what the image holds. So in this example, in the video, a picture of a number 8 being drawn is fed into the network. And with each weight of a neuron, with each weight of a pixel, the algorithm is able to identify that, given the pattern, that this should be an 8 being displayed in the picture. And so it's really just an interesting way of recognizing that an algorithm, such as a neural network for this particular example, is able to identify what would otherwise be hard for a program, an AI, a computer, uh, hard to recognize. And so that's just a really neat way of showing how neural networks work. And then we move on to the universal approximation theorem, which is just a way of saying that an algorithm or a neural network, as we discussed before, is able to approximate what it is that is being uh, fed to it, or what is the goal of the algorithm. So, a neural network that can approximate any continuous function within the bounds of an input. The video explains this by using just a piecewise function, a continuous linear function. And what a neural network does is that for a particular bound, a particular input, uh, the the pattern, uh, the trend that the linear graph follows is being approximated to the point where, given enough of these approximations, it can actually follow the trend, the flow of the graph, recognizing patterns, and through enough iteration is able to match what is being shown or what is being asked of it. And that is about it. Thank you so much, and I will see you guys next time.